Okay, so we are continuing our work with area between curves and starting to get into some more complicated examples. So this example, we have curves that intersect 3 times or more. Example 4 says, find the area of the region between the graphs of f of x is 3x cubed, subtract x squared, subtract 10x, and g of x is negative x squared plus 2x. We've been given a picture here, and you might be able to visually see where these functions intersect, and we will need that later. But first we need to figure out which one is the top function and which one is the bottom function. So I know basically from the shape of a cubic function that a cubic function can have at most 3 zeros, 1, 2, 3. That looks like this is matching the purple curve. So this function right here is my f of x, and then that's the same function. This black function right here is the g of x. Now, important thing here is we are going to need to use 2 different integrals because f of x is the top function for a little while, but then it switches to being the bottom function. The easiest solution would be to do the integral from a to b absolute value of f of x minus g of x, but that's tricky to do because we don't actually know how to integrate an absolute value function. So instead, what we're going to do is we're going to split it up into an integral from a to b of something dx, and then an integral from b to c of something dx. So we're going to split our integral up in the middle of the interval. So let's go ahead and actually do that. One thing I want to point out is that if you were to set these functions equal to each other, that's how you would find the points of intersection. However, we don't have a nice, clean way of solving for a cubic function. Wait, maybe this might work out. Let's try this. If I try to bring everything to one side, I could get rid of the negative x squared. Oh yeah, this will work out nice. And then I could make this minus 12x equals 0. I could factor out an 3x, and then I would have x squared subtract 4 equals 0. Then I would have 3x, x minus 2, x plus 2 equals 0. So we can pretty clearly see our intersections are at 0, 2, and negative 2. We could see that from the graph, but I'm glad that we went ahead and did that algebra. So this ordered pair is at negative 2. Don't really care about the y. 0, clearly 0, and then 2, 0. So let's go ahead and set up our integral. Our integral is going to be composed of 2 different parts. So we are going to do one integral that goes from negative 2 to 0. And on that integral, we're going to have the f of x first. And then we're going to have a second integral that goes from 0 to 2. And on that one, we're going to have the g of x first. Now, one thing that you hopefully notice is that the only difference between these 2 integrals is that these are opposites. So I'm going to go ahead and just do one of the integrals, work it out, and then we'll figure out how to do the second one. So I'm going to erase this for now. Let's go ahead and combine our like terms. So I have 3x cubed subtract 12x dx. And then I'm going to actually take the antiderivative. So I have 3x to the 4th over 4 subtract 12x squared over 2. Now I'm going to actually evaluate. You put the top number in first, so you start with a 0. So 0 plugged into both of these results in 0. That doesn't always happen, so be careful with that. And then I have 3/4 of 16, subtract 6 times 4, so subtract 24. So I have 12 subtract 24, I have the opposite of negative 12, or I have positive 12. So I know that this region right here is just 12. Now the only difference for the second region that I need to do is that I'm going to be integrating from 0 to 2 the opposite integrand. So because it was the opposite order of subtraction, it's just going to be positive 12x subtract 3x cubed dx. And that means that my antiderivative is just the opposite. It's 6x squared subtract 3/4 x to the 4th. But now we are plugging in 2 first and then 0. So I end up with 24, subtract again, that's going to be 12, and then subtract 0. So this part ends up being positive 12 as well. And it's kind of interesting because when you look at this, these are obviously different shapes, but we can see from the symmetry that we're going to be getting very similar answers. Although the order of subtraction was opposite when I plug 2 into each of these functions versus if I plug negative 2 in, when they square, it's going to end up being positive. In this case, I ended up with negative 12, but then it was subtracted, so it ended up with positive 12, and in this case, I ended up with 12. So my total area is just going to be adding these together. So my total area is 24. And technically, maybe we want to write that this is square units because this is actually an area calculation.